So I'm going to go through the answers to these waves questions. Make sure you can mark your work. So the first thing is you need to be able to label wavelength, amplitude, peak and trough. So this is a peak, this is a trough. A wavelength would be like from peak to peak. You should really, or trough to trough, you should really draw that lines in the middle of those to get them really accurate. So they're wavelengths. And then an amplitude is from the middle line up. Okay? Now the wave equation is wave speed equals frequency times wavelength. Okay, so we're going to use some of that now. The other equation we're going to use, I'll show you in a minute. But let's have a look at this. So a car is travelling 60 kilometres per hour. How fast is it travelling in minutes per kilometre? So if we can do 60 kilometres in an hour, how many minutes does it take to do a kilometre? So that's going to be 1 kilometre per minute, because there's 60 minutes in an hour. Okay. Then light travels 300,000 kilometres in 1 second. How long does it take light to travel 300 metres? So we would use time equals distance divided by speed. Distance is 300 and the velocity, if this in standard form, that's 300,000 times 10 to the 3, which is the same as 3 times 10 to the 8. So 300 divided by 3 times 10 to the 8 is 1 times 10 to the minus 6 seconds. Okay. How long does it take light to travel 300 millimetres? So time is distance divided by speed again. And the distance is 300 millimetres. That's 300 times 10 to the minus 3 divided by 3 times 10 to the 8. So that is 1.1 times 10 to the minus 11 seconds. Right, the speed of sound in metal is 1,000 metres per second. What is the wavelength if the frequency is 2 kilohertz? So wave speed is frequency times wavelength. So there's the triangle if you need it. So we want wavelength. So wavelength is velocity divided by frequency. The velocity is 1,000 and our frequency is 2 kilohertz. So 2 times 10 to the 3 hertz. So kilo is 1,000. So that's 0.5 meters. Again, we want wavelength for this one. So it says, what if the wave is 2 megahertz? So the speed is still 1,000 and a mega is a million. So 1 times 10 to the 6. So that is 5 times 10 to the minus 4 meters. Okay, next page. Speed of sound in air is 330 meters per second and the speed of light is 300 million meters per second. What is the frequency of sound waves of wavelength 100 millimeters? So frequency is speed divided by wavelength. Okay, and the speed of sound is 330 and the wavelength is 100 millimeters, so 100 times 10 to the minus 3. Okay, and that gives me an answer of, I just need to check that. I have worked it out. I think I've worked it out wrong. 330 divided by 100 times 10 to the minus 3. Yeah, that's right. So the 3,300 hertz, or 3.3 kilohertz. What is the frequency of radio waves of 100 millimeters? So electromagnetic waves travel at the same as the speed of light. So frequency is velocity divided by wavelength. So the velocity is 3 times 10 to the 8 and the wavelength is again 100 millimeters. Okay, and that gives me an answer of 3 times 10 to the 9 hertz. Or we could say that's 3 gigahertz. If you could freeze ultrasound of wavelength 5 millimeters, as it travels through tissue, how many waves would there be in 1 metre length? This quantity is called wave number. How is it related to wavelengths? We're going to make an equation here. So we've got 1 millimetre and it's made up of lots of 5 millimetres. So we do 1 divided by 10 to the minus 3, which gives us an answer of 200. So if we give these values, that's our wavelength and that's the number of waves. So 1 over wavelength equals n. So that's how they're related to each other. That's the equation. What quantity is the reciprocal of wave frequency? 1 over wave frequency is t, which is time period. Next, ripple tank waves of length 2 centimetres travel at 15 centimetres per second. As they pass into shallow water covering a glass sheet, they slow down to 10 centimetres per second. Find out the original frequency of the waves and calculate their new wavelength. So when they move into that shallower water, they don't change their frequency. So what we're going to do is we're going to say F equals V over lambda. Okay. So for the first one, that's 15 over 2, which gives us a frequency of 7.5 Hertz. The frequency stays the same, and we want wavelength in the second one, so that's V over F. So our V is 10 and our F is 7.5, so that gives us a wavelength of 1.3 centimetres. Right, this is quite a hard question, number 11. If a thunderclap comes 1.5 seconds after the lightning strike, how far away was the strike? So we're going to use the idea that distance is speed times time, and the distance they travel is the same. So the velocity times the time of the lightning is the same as the velocity times the time of the thunder. Okay, because the problem is we don't know t, but we can say that t2 is the same as t1, but it's got 1.5 seconds added on here. So I'm going to substitute this into here. So v1 t1 equals v2 t1 plus 1.5. Then I can get my brackets out. So v1 t1 equals v2 t1 plus 1.5 v2. Okay, then I can substitute in my values and rearrange this. Okay, so v1 is the lightning, so that's 3 times 10 to the 8. v2 is the thunder, so that's 330 metres per second. I've run out of space, so I'm just going to go up to the top of my page to do it there. So all I'm doing is substituting my numbers into this. Okay, so 3 times 10 to the 8 t1 equals 330 t1 plus 1.5 times 330. I think that's 400 and something, 495. So then I'm going to take this to the other side. So 3 times 10 to the 8 t1 minus 330 t1 equals 495. Do this calculation to get t1 out, and you end up with t1 is equal to 2.65 times 10 to the minus 6 seconds. But the question doesn't ask for the time, it asks for how far away is the strike. So now we just need to substitute this into distance equals speed times time. So distance equals velocity times time. So our velocity of the lightning is 3 times 10 to the 8, and the time is 1.65 times 10 to the minus 6, which gives us an answer of 795 metres. Okay? FM or local shortwave radio is emitted at 95.2 megahertz. So mega is a million, so 92.5 times 10 to the 6 hertz. What is the wavelength? So wavelength is velocity over lambda, so that's 3 times 10 to the 8 because it's an electromagnetic wave, over frequency, divided by 92.5 times 10 to the 6, which gives us a wavelength of 3.15 meters. Okay? And then the medium wave band are transmitted for the BBC World Service at 460 metres. Calculate the frequency. So frequency is velocity divided by wavelength. So that's 3 times 10 to the 8 over 460, which gives me an answer of 0.65 times 10 to the 6, which is 0.65 megahertz. Okay, don't worry too much if you didn't get question 11 right. That's quite difficult, as is question 10. Okay, but the rest should have been fairly straightforward. Let me know if there's any problems in the Google Meet. Okay.